Right, so we're going to do a couple examples of the Jefferson method of apportionment. So I basically have the same problem. It's going to be written down 3 times, and we're going to go from one page to the next to kind of give you an idea of what's going on. So what I started with was, what we're going to start every problem with is finding our total population. So we add all the way down, we get a total population of 385. So we're literally just adding these numbers, and it equals 385. You will be given the amount of reps that has to be given to you, and we use the total population divided by 30 to get our standard divisor. We're going to round that to the nearest hundredth. 385 divided by 30 is 12.83. So the first thing we always need to do is get our standard divisor, and we do that by total population divided by reps, and our standard divisor in this case is 12.83. And then I'm going to divide each of the 8 individual group populations by 12.83. So for example, 47 divided by 12.83 is 3.66. 37 divided by 12.83, 2.88. 84 divided by 12.83, 6.55. 26 divided by 12.83, 2.03. 52 divided by 12.83, 4.05. 97 divided by 12.83 is 7.56. 13 divided by 12.83 is 1.01. And 29 divided by 12.83 is 2.26. And that gives me my standard quota. We're always rounding normally to the nearest hundredth. Then I'm going to take my lower quota. That's always the number in front of the decimal point. So 3, 2, 6, 2, 4, 7, 1, and 2. So my total lower quota is 27. Now, the first example I'm going to give is we're going to almost kind of do a guessing check. Now, what essentially you need to do is we need to change this lower quota, we need to change the standard quota to a number lower so that when we retake the standard quotas, my lower quota becomes 30. My lower quota is 27 right now. So literally I need to move 3 reps up. 3 of the 8 groups are going to get an extra rep. And what we need to do is we need to figure out a number that's going to allow me to divide all 8 populations and create a lower quota that is 30. So my first try is going to be, okay, so the first guess I'm going to make is I'm going to guess 12.5. A little bit lower than 12.83, and we're going to see how it changes the standard quotas. So if I divide all these populations by 12.5, I get 3.76, 2.96, 6.72, 2.08, 4.16, 7.76, 1.04, and 2.32. Now it doesn't change my lower quota. My numbers are still the same, 3, 2, 6, 2, 4, 7, 1, and 2. So I get 27. But it's not useless. If you notice, 2.96 is very close to the next number. So that's going to move up. And if you notice, 6.72 and 7.76 are also close to the next number. Now, so is 3.76, but remember, the 47 population is much lower than 84 and 97. The bigger populations will always move quicker. So this 7.76 is going to get to 8 quicker than this 3.76 is going to get to 4. And this 6.72 is probably going to get to 7 before the 3.76 gets to 4. Now my next guess is my answer. I guess the number 12. So we go a little bit lower. And if you notice, when I divide all 8 populations by 12, I get 3.91, 3.08. So this one goes from 2 to 3. This is 7.00. So therefore this goes from 6 to 7. 2.17, 4.33, 8.08. So this goes from 7 to 8, and then 1.08 and 2.42. So when I add up my last column, I end up with 30. Essentially what I need to figure out is which 3 groups are moving when I need 3 votes. If I needed 4 votes, it'd be what 4 votes are moving. Okay, but in this case, I need 3 to move. It's usually going to be the numbers that are closest to the next number, like 0.88, or the biggest numbers, 0.55 and 0.56, will get to their next number when you move the standard divisor a little quicker than the 3.66, but it is a guessing check game. Okay, sometimes they don't move quick enough, sometimes they move too fast. So that's how we get our answer using Jefferson method.